Hi, Ree. I wanted to go through the redos. So this is the summary page. This will tell you the points that you've earned, but I want to go through the redos first. So let's see. In problem 1, you were computing a confidence interval, and there's a problem here with the margin of error. So what you want to do is you want to go back and look at the formula for the margin of error. The good news is once you add this one little thing, everything else will automatically update. Okay. Yeah. Just go ahead and put in the correct formula for margin of error. So these are things that you should be computing. So there's something that's kind of missing here. Okay, everything else looks good. I like the way you have it laid out. And I like the way you have a sheet for each problem too. That's really good. Okay, and so the same sort of thing will apply here. So you have the confidence, the percentile. That's good. Again, this is something that I would compute. Let me just give you a piece of advice. If you want to do this, there's a couple of ways of doing this. You can compute what's called alpha and divide it by 2, or you can compute the percentile. So the percentile is equal to this plus half of what's in the wing. So what's half of what's in the wing, the tail? Well, it's this divided by 2. Okay? You'll get the same answer, but it'll keep you from making small errors, okay? But again, this point regarding the margin of error is still relevant. You want to go back and make sure that you know how to do that. So the good thing is you're making the same error, and it's easily corrected. You just need to go back to the formula for margin of error. Okay, 8.5. So confidence intervals are kind of tricky. So this is what you want to look at. So I would go back, look at the material on confidence interval, and here's the thing about the confidence part. The confidence has to do with the method. Very often people think it has to do with the probability that the value is in there. It doesn't. The mean is either in there or it's not. There's no probability for a given confidence interval. Okay? So while this part is true, we do think that the average time spent, I'd be a little careful with most people, but we do think that the average time spent for most people is between here. But we have to add another statement regarding the confidence. What is the confidence talking about? And I'll be honest, this is a hard thing to put into words. Okay, but we want to try to comment on the confidence. What is the confidence about? See, this statement would be true for a 99% confidence interval, 95% confidence interval, 98% confidence interval, 90% confidence interval, whatever, because you haven't talked about the confidence. So where does that come into play? Okay, 8.11, okay, you're computing the confidence interval. Okay. B5, hold on, B5, B7. Looks good. You gotta be careful. Yeah, so there's a problem here. So you want to be careful what you're putting into the T for the test statistic. For the T score, not the test statistic. Sorry. You want to be careful. This is actually a critical value. You want to be careful what you're doing, what you're putting in here. So you're putting the wrong thing in here. So you want to be careful about that. And of course, that's going to throw this off. Now the good news is that you got the margin of error here. You used the right formula here. So this kind of answers how to do 8.1 and 8.2. Okay? Even though you're using the sample standard deviation, the same general formula is used whether or not you know sigma. So this is kind of answering how you get the margin of error. But it's going to be wrong because this is going to be wrong. However, once you correct that, this should automatically update. Okay, everything else looks good. This is just asking you for the decision rule. This is just step 4. So if we know alpha, what's the decision rule? If we know the value of alpha, they just want you to state the decision rule. So actually there's very little to do. So if you go back to the fourth step in our hypothesis test, you'll see what I mean. Okay, let's see, 8.16. So you're doing a confidence interval, so this is a percentile, that's good. Same problem as before. You're putting, you're doing two things here. So there's a problem with how you're computing the critical value and a problem with how you're computing the margin of error. So there's two problems. One is the computation of the critical value. I'm just going to use CV. And the other is the formula for the margin of error. Notice it's hard to tell when you make a mistake. This answer looks reasonable, okay? It doesn't look far off. It's not crazy. It's not like 0 and 150. So you have to be careful because you won't be able to tell from the numbers themselves. Okay, so in 9.1 we're doing hypothesis tests. I'm not sure what happened here. So here's what you want to, here you're doing confidence intervals. Sorry, it's not hypothesis tests, confidence intervals. So the basic formulas are actually very, very similar. Okay, so here you just want to do a confidence interval where now you know the sample standard deviation. So you don't know sigma here. You know the sample standard deviation. But the problem is the same. So what I'd recommend is I actually made 4 videos, one for each section, one for 8.1, one for 8.2, one for 9.1, and one for 9.2. I'd go back and look over that. So this whole thing will be a redo. Okay, for 9.4, basically the same thing, right? No, I'm sorry. This is actually the one where you want to state the decision rule. Hold on a second. 8.12b, that was just asking you for the degrees of freedom. So let me copy and paste this. I want this over here. Yeah, this is just asking you for the degrees of freedom. This is where you want to state the decision rule. And let me go back. This is just asking you for the, I think it's either degrees of freedom. Let me just check real quick. It's either degrees of freedom or critical value. Let me just see real quick which one they wanted. They just wanted the critical value. You need the degrees of freedom. You have to compute the critical value. Okay. And again, the videos from section in 8.2 can help you with that. All right. So here we just want to state the decision rule. All right. Let's see. So I'd like you to state this in a little clearer terms. Like, what would happen in a courtroom if there was a type 1 error? Okay? So these statements aren't necessarily wrong, but what they want you to do is they want you to explain in just everyday words what would happen in a courtroom. What is the consequence of making a type 1 error? Okay, so a good thing is to, write down what I would do, because this is actually a really good exam question, is, write down what H naught is, write down what the null hypothesis is, okay, write down what the alternative is. Whoops, what did I do there? Come on. And you're absolutely right. A type 1 error is when you reject the null hypothesis even though it's true, and a type 2 error is when you don't reject the null hypothesis when it's false. So I would write down what H naught and what H1 is, what the null and the alternative are. In a courtroom, the null is what we assume, right? The alternative is what we're trying to prove in a courtroom, and then it'll be a lot more clear. Okay. Okay, so in this problem, kind of a strange problem because they actually do it a little differently than what you'd probably do in real life. You'd probably switch the hypotheses, but let me just make sure I'm on the same page here. So type 1 is where right, the null hypothesis is that it's unsafe. The alternative is that it's safe. So H naught is that it's unsafe, and the alternative is that it's safe. Okay. So when we make a type 1 error, we reject it when it's true. We reject the null hypothesis when it's true. So again, you need to be a little more clearer as to what this translates into. What's going on? What are the real world consequences of this, okay? So the consumer groups, okay, so we already know, let's kind of work backwards. We know that the consumer groups are trying to avoid somebody saying something safe when it isn't, okay? So this should kind of tell you what sort of error you're looking at. I would go back and look at this. Okay. And lobbyists are trying to avoid it being unsafe when it's safe. So you want to go back and look at this. And these are extra credits. You don't have to, okay? You're kind of on the right track here. The answer's in the book, I'm pretty sure, because it's a very standard way. There actually is a way of lowering both. Okay? It may or may not be obvious. I don't think it would be necessarily obvious, but the book can tell you how to do that. It is in the book. Since it's extra credit, I want you to dig and look around a little bit and read a little more about it. Okay, let's see. 9.14. So now we're doing hypothesis tests. So let me see. Okay. So let's see, for 14 we do 2 tail or 1 tail. I'm trying to remember. Hold on 1 second. What did I do with that? I'm trying to. Okay, so here I asked you to do a 1-tail test. That's why I was being a little careful. So you want to go back and look at the hypotheses. For 14, I asked you to do a lower tail test. Okay. The test statistic is what you're computing. Let's see. And again, I need to see how you're computing that. So you want to show me how you're computing that. The p-value, again, I need to see how you're obtaining that. Okay, I see from here how you got that. Okay, you just copied it. There's really no need to copy stuff. You can just, but that's okay. Reject the null hypothesis. Okay. So we're going to have to be careful. Well, I'm not going to tell you if this part's right or wrong. I want you to redo this as a lower tail test. Okay, so you have to redo as a lower tail test. This is what we had in the instructions for the homework. Okay, 9.16. This looks good. Again, you know, do everything. Do all your computations off here. You want to try to. You want to try to do this, and you have to be careful because this is not correct the way you're computing this. I would definitely make sure this formula is not correct. I would really make sure that you're doing this correctly. I would take another look at this, and I would compute this in Excel. Okay, I mean I don't know where you're getting this values from. I want to see how you're computing it because this formula is wrong. I can tell you that right now. So I'm not sure if you're doing this correctly. Okay. P-value. Yeah, it looks all right. Let me just check one thing real quick. Yeah, that looks good. For 14? No, I'm sorry, 16. I was thinking it's 14. Yeah, it looks good. Okay. So yeah, so you're greater than you're greater than 0.1 here. So you're going to reject. Okay. Okay. Good. Good. Okay. So just make sure that this is correct. Yeah. 9.18. So I guess we need to do that one. That's a total redo. And 9.18, you're basically doing hypothesis test where the standard deviation is not known. Okay, so this is that video from section 9.2 that I was referring to, and I would just go back and look at that. Okay, let's see. 9.19, same thing basically. All right. Good. So you can't use a t-test when the data is skewed and the sample size is small. Okay. And you can use the t-test because the sample size is big enough, and it is skewed as long as it's as long as the sample size is large enough, it will take care of the skewness though. Okay, 25, yeah, that's another hypothesis test. And let me see 20 real quick. I'm sorry, 31. Yeah, so 31 came from data. So basically they wanted you to take that data set and compute this, the sample mean and the sample standard deviation. So they didn't give it to you in 31. They wanted you to actually compute it. Okay, so those are the redos. You have till Friday, 5 o'clock. And if you have any questions, feel free to ask, okay? One thing I just say real quick, it's always easier to call than to text. These problems are really hard because you can see there's formulas and everything. If you text or Skype, it makes it much, much easier. It's better for you. It's much more time efficient for both of us. So I'm sure that you're busy and you have other things that you want to do than just statistics. And if you talk it through, you can do it very, very quickly. So I would really urge you to do that. I know you've been texting, and it's good that you're contacting me. I totally urge students to do that. That's a great thing. But I think if you have involved problems, it's not just a simple question. Then, like I suggested last weekend, I think calling is definitely better. Okay, so if you have any questions, I have those 4 videos. They address problems from each section. I think they should pretty much help you out with most of the redos. But if you have any questions, always feel free to contact me. Thanks.